Welcome to today's lesson. Today we will learn about angle properties, angle relationships and properties of geometrical figures. To start off, we'll look at the definition of terms that are used in this topic. We know a point. A point is shown using a dot and is generally labeled using uppercase letters. So if we have point A, we'll use a dot to show that this is point, and then we label using letters, but they should be capital or in uppercase. That is another point. We call it point B, and you realize that when we are labeling, we use uppercase letter B. This is point C, shown using a dot, and we label using a capital or uppercase letter C. So these three, we call them points. So a point represents a position. These 3 points here represent position. So we have position A, C, and B. And we have said you indicate using a dot and an uppercase letter. What happens when we join 2 points? For example, let us join point A and point C. If we join point A and point C using a straight line, you realize that we get a line from point A to point C. This is what we call a line segment. AC, we get what we call a line segment or an interval. Those are values in between A and C. So this is a line segment. If we join B to C, we'll also have another line segment. So when we join A to C and C to B, we have intervals A, C, and another interval C, B. You realize that we have joined the 2 lines and they meet at point C. They meet at point C. So what do we call C? C then becomes a vertex. This is vertex where 2 lines meet. Vertex is a point where 2 lines meet. So when we join the 2 intervals, so the 2 line segments, and they meet at point C, we call this point vertex. In plural, vertices. So if we have 2 or more points where lines meet, we call them vertices. We also have, when we join AC and CB, there will be an angle formed. There will be an angle that is formed that can measure any degrees. So this angle here is called This angle at the vertex is called angle ACB because it is found at the vertex C. So C should be at the middle where the angle is. Angle ACB because it is in between the two lines that have joined together. So we call it angle ACB, or it can also be called angle BCA. If we start from this point, we'll call it angle BCA. Angle is represented by this sign here, angle BCA. Or it can also be denoted as angle ACB, can also be written as this way. Or if we start from the other side, that also reads angle BCA. So we mean this angle here, the angle at the vertex C between the two line segments. When we joined these two line segments to form an angle, this AC and CB are also called arms. They are also called arms. The arms AC and CB. So now let's move on and look at the different types of angles that can be formed as a result of joining two or more segments. So let's look at the different types of angles that are formed when two line segments meet to form an angle. So we have an acute angle, and this is an angle that is measuring more than 0 degrees but less than 90 degrees centigrade. 90 degrees. So if we have an angle that is more than 0 degrees but less than 90, that angle is called acute angle. And it is can be drawn this way. We also have another angle that we call right angle. This is measuring exactly 90 degrees. And it is written this way. This is a right angle, 90 degrees angle. We have an obtuse angle. This one is greater than 90 degrees, but less than 180 degrees. So this is an example of an obtuse angle. It is more, you see that it is more than 90, because if it was 90, be somewhere like that. So it is more, you see that it is more than 90, but it is not, it is less than 180 degrees. We also have another type of angle that we call straight angle. Straight angle is measuring exactly 180 degrees. 180 degrees is an angle of a straight line. We have another angle that we call reflex angle. A reflex angle is greater than 180 but less than 360. So an example of a reflex angle is this one that is outside. You can see that it is more than 180, but it is definitely not 360 degrees. Then we have a revolution. A revolution measures exactly 360 degrees. 360 degrees. And this one is represented as this is 360 degrees. It is a complete turn. You start from a point and you go round until you come back to that point. That is called a revolution, a complete turn, measuring exactly 360. So then, these are the different types of angles that can be formed when two line segments meet. Let's look at examples. We also have other types of angles, and one of them is called adjacent angles. We have these angles here that are formed by joining these three lines at vertex, and they meet at the vertex C. We have angle ACB. Angle ACB. We are talking about this angle here. Angle ACB. Angle ACB is said to be adjacent to angle BCD. Adjacent to angle BCD. What do we mean by adjacent angles? We mean they are angles next to each other. Angles next to each other. Angles next to each other means they will share a vertex. They will share a vertex, and they will also share a common side. So you realize that angle ACB, the vertex is C, and also angle BCD has a vertex at point C. So we are saying adjacent angles share a vertex, and they also share, there is a common side between the two angles. Common side. So you realize that BC, this arm here, BC is a common side to the two angles. So this, if they have these characteristics, then we call these two angles adjacent to each other. They are normally next to each other, and because they are next to each other, they will have a common side and they will have a common vertex. We also have adjacent complementary angles. We have said adjacent means they share a common vertex. They have a common vertex and they have a common side. But we can go ahead and look at adjacent complementary angles. Complementary angles normally are these two angles that add up to 90 degrees. Two angles adding up to 90 degrees. That means when we add angle A measuring A degrees and an angle measuring B degrees, they should give us 90 degrees. So when they give us 90 degrees, then we say those two are complementary angles. They are adjacent because they have the characteristic of a common vertex and a common side. But complementary angles alone does not necessarily have to be adjacent. We can have angles which are complementary but not necessarily adjacent. For example, these two angles here are not adjacent, but they can add up to 90 degrees. We still say that A and B are complementary angles because they add up to 90 degrees, but they are not adjacent. So remember that we have said complementary angles are two. They are only two angles which when you add them together, they give you 90 degrees. So we will say that A is a complement of B. A is a complement of B because both of them add up to 90 degrees. It is also possible to have three or more angles in a 90 degrees. It's possible to also have three or more angles in a 90 degrees angle. For example, we have angle A, B, and C. All the three, when you add them, give us 90 degrees. We are saying these ones are not complementary angles because they are three. Complementary, they should be two, which their measure add up to 90 degrees. So when we have these angles here, we say A, B, and C are not complementary. We also have angles that we call adjacent supplementary angles. Supplementary angles are two angles which their measurement, if you add them, give you 180 degrees. We said this is a straight angle giving us 180 degrees. That means so x and y, if you add, should give us 180. We say these are supplementary angles. Remember, supplementary angles are only two angles, which when you add, they give you 180 degrees. So we will say that x is a supplement of y. X is supplement of y, or y is supplement of x. Again, these are adjacent angles. If you can remember what we said about adjacent angles, they have a common vertex, plus they have a common side. So we call these two adjacent supplementary angles. But again, we have said supplementary angles on their own don't have to be adjacent. We can have angles which are add up to 180, but not necessarily that they are adjacent to another. So those are also supplementary angles. We can also have three or more angles on a straight line, that will add up to 180 degrees. When we have three or more angles, these ones are not supplementary again, because we have said for them to be supplementary, they must be two angles. But we can have more than two angles in a straight angle. Angles at a point, or angles in a revolution, we have said that one will make angles in a revolution make a complete turn. So when we add this angle that is measuring s degrees plus r degrees plus q degrees plus p degrees, and it gives us 360 degrees. This is a revolution because it makes a complete turn. When two straight lines meet, we have two straight lines, line AB and CD. When they cross at this point, we have angles that are formed. And we have angle X measuring X degrees, and this one is also measuring X degrees. These two angles here are called vertically opposite angles. Vertically opposite angles means this is the vertex. Vertex in this case means vertically opposite in this case means they share a common vertex. The reason we are calling them vertically means they share a common vertex, but then they are on opposite ends of each other. Another one is on top of the other, they are opposite. So vertex in this context means they are vertically opposite, meaning they share a vertex, but it is opposite on top. Another one is on top of the other. So when we have vertically opposite angles, these angles are equal. These angles are equal. That's why we are putting here X and also here X. So vertically opposite angles are equal. These ones are also vertically opposite. They share a vertex, but you see, this other angle is on this end, and this one is on the other side. They are opposite ends. So they are also equal. If this is y degrees, this will also be y degrees. If one of the angles in vertically opposite angles is 90 degrees, if that angle there is 90 degrees, it will follow automatically that this angle is also 90 degrees. And then, because angles in a straight line add up to 180 degrees, this will also mean that is also 90 degrees, and then this will also be 90 degrees. So if one of the angles in vertically opposite angles are 90 degrees, then all the angles will be 90 degrees. If they are 90 degrees, if this angle here is 90 degrees, then that means line CD is perpendicular. Perpendicular is represented this way. Line CD is perpendicular to line AB. Because what do we know about perpendicular lines? Like perpendicular lines normally meet at 90 degrees. So if this line meets this line at 90 degrees, then this means that these two lines are perpendicular to each other. This is how we represent perpendicular lines. Line CD is perpendicular to AB. With that knowledge then, let us look at how to find the missing angle, the value of the missing angle. So determine the value of the pronumeral. Pronumerals are these letters here that represent the value or the measurement of this angle. So the letters, we call them pronumerals because they represent numbers. So determine the value of the pronumerals in this diagram, giving reasons. So find A. What is the measurement of A? According to this diagram, we are told that this angle here is 90 degrees. And one of the angle is 30 degrees. So then what do we say? Because A and 30, they are in 90. If we add the two, then they should give us 90 degrees. Reason? We are told to give reasons. So the reason why we are saying A plus 30 degrees should give us 90 is because these are angles in a right angle, or angles in 90 degrees angle. So we say we subtract 30 on both sides so that we eliminate this 30 on this end. If we subtract 30 on this end, then we also subtract 30 on this other end. So if we subtract 30 here, we remain with 0. Then 90 minus 30, we have 60 degrees. So what is the value of A? That is 60. 60 degrees. Then we are also told to find angle B. So what is the value, or how do we calculate the value of B? Because already we have found the value of A. So this angle here is 90. So we will say this is already found. This is 60 plus 30, then that makes 90. So we say 90 plus B. That will make a complete turn, isn't it? A complete turn, that is a revolution. And we have said a revolution always measures 360 degrees. So we say 90 plus B should give us 360. What is the reason? Angles in a revolution. That is enough reason. You don't have to write so many statements. Angles in a revolution add up to 360 degrees. So 90, we are supposed to collect the like terms. What do? We subtract 90 here, and then that will mean we subtract 90 from this other side also. If you subtract correctly, what do we have? 270 degrees for B. Let's look at another example. Find the value of A and the value of B. Let's start with B. What do you think is the value of B? The value of B is 65 degrees. Why are we saying it is 65 degrees? If you can remember the definition of vertically opposite angles. We said that vertically opposite angles are equal. So because these two lines are crossing, they meet, and then we have these two angles in between the two lines that are meeting. We call them vertically opposite. So then B is 65 degrees. What about A? A plus 65, that should give us 180. Why do you think so? These are angles in a straight line. The reason is angles in a straight line. And we said angles in a straight line add up to 180. So because you realize this is a straight line here, so 65 plus A should give us 180. Let us now collect the like terms. We subtract 65 here, then we'll also subtract 65 the other side, so that we remain with 0. So A is 115 degrees. So remember to give reasons if you are asked to give reasons. Let's see if we have understood what we have just learned. We are told to complete the following sentences. We have these angles here. We have 20 degrees, 70. We have 50. We have 130. Then we have a right angle here. So we are told 20 and 70 are dash angles. What do you think? 20 and 70. If you add 20 and 70, what do you get? 90 degrees, isn't it? So 20 and 70 are complementary angles. They are complementary angles. Remember the complementary, we said there are two angles which add up to 90 degrees. Then if 20 and 70 are complementary angles, then that means 20 is the dash of 70. It is the complement. 20 is the complement of 70 because both of them add up to 90 degrees. Let's look at the next one. We have 130 degrees and 50 degrees. 130 and 50 degrees. These two angles here. They are dash angles. What are they? If you add 130 and 50, what do you get? You will get 180 degrees. So that means they are supplementary angles. (130 and 50 degrees are supplementary angles. Then if 50 and 130 are supplementary angles, then 130 is the dash of 50. It is the supplement. Supplement of 50 degrees. Then the angles in a diagram form a complete. There are 5 angles. The 5 angles in this diagram, all the 5. When we add 90 plus 70 plus 20 plus 50 plus 130, all these angles here, what do you get? You realize that we get a complete turn, which we said it is called a revolution. So the angles in a diagram form a complete revolution. Complete revolution. 360 degrees. So let's look at another example. Let's look at this other example. Consider the diagram given there. Name an angle that is vertically opposite to angle A or B. So which is this angle? Let's identify angle A or B. We said that angle, that means the vertex is at point O. A or B. So we're talking about this angle here. Which angle is vertically opposite? You realize this is the angle. What do you call that angle? D O E. Angle D O E. You can also start from this end and say angle E O D. So these two angles are vertically opposite to each other. Name an angle that is complementary to B angle B or C. So let's identify angle B or C. B or C. This angle here. The angle that is complementary. So that means you should be able to remember the meaning of the word complementary, and we have said it means two angles which add up to 90 degrees. So which angle is complementary to angle B or C? You realize that we are given that these two angles here add up to 90. So it should be this angle BOA. Angle BOA. Add the two, they add up to 90 degrees. You're also asked to give an angle that is supplementary to angle AOE. Supplementary to angle AOE. So let's identify angle AOE. So this is angle AOE, angle AOE. They are talking about this angle here. So which angle is supplementary to this angle? Meaning they add up to 180 degrees. These are angles in a straight line. So which angle is missing to make a straight line with this? You realize it is angle DOE. So this will be angle DOE. This angle here. Angle DOE. Then you're asked to copy and complete AD. That is line AD. Line AD is, we said this sign means perpendicular. Perpendicular means they cross or they meet at 90 degrees. So line AD meets at 90 degrees with which line? So we look at AD. Which line, which other line meet with this line at 90 degrees? You realize that it is line, this line here, CO. So AD is perpendicular to line CO. Then we are told which line also is perpendicular to OD. Let's see OD. This line OD here, this is line OD from here to here. This line meets with which other line that will have an angle measuring 90 degrees? You realize it is the same. Line CO. So again, CO is perpendicular to line OD. So we have said this one means perpendicular. So again, we have this other example. Write down algebraic expressions for the size of angle ABC. So which angle are we talking about? Angle ABC. B is the vertex. We're talking about this angle here. Algebraic expressions. So you realize that we are told from here to here, the whole of this angle is 90 degrees, and part of it is x degrees. So what is the expression? So angle ABC is equals to 90 degrees minus x degrees, because both of them add up to 90. So we subtract from 90 x, and that will give us this angle here. This again is still testing our knowledge on whether we have understood complementary or supplementary angles. ABC. What is the measurement of angle ABC? This is angle ABC, algebraic expression. So you realize that these two angles are supplementary angles, meaning they add up to 180 degrees. So angle ABC is 180 degrees minus x degrees. So what is the size of angle ABC in this case? So they are talking again of this angle. We are told that this other outside angle is measuring x degrees. So what is the algebraic expression of this angle? That will be 360 degrees minus x degrees. Remember, this is a revolution, and we have said that the revolution should be 360 degrees. So because all of it is 360, and we are told here is x, we subtract. So we are asked to write down equations for these diagrams. This time around, they are not expressions, but we are told to write the equations. Equations means now we include the equal sign. So what are the equations? Algebraic equations for these angles here, the two. So you realize again, this is a complete revolution if we add A and 3B. So the equation, you must include an equal sign. If we add A and 3B, they should give us a complete revolution, which is 360 degrees. So for this diagram, what is the equation, the algebraic equation? We have three angles here on a straight line. So we know, what do we know about angles on a straight line? They are add up to 180 degrees. So we can say we can include all the angles, saying A degrees plus 90 degrees, because here we are already told it's a right angle, meaning it is 90 degrees. And then this is B. So when we add all the three, should give us 180 degrees. So let us collect the like terms. The like terms here, we have 90 and 180. We put them together. If we subtract 90 from this side, we'll have 0. Then we also subtract from this side. So our expression, or our equation will be A degrees plus B degrees should give us 90 degrees. Or we can simply just, instead of starting with 180, because already we have 90, we know that for a straight line, if we already have 90, we say 180 minus 90. That means the two, A and B, should give us 90 degrees. So we can just start from here, or we can follow this route, but we'll have the two, giving us the same answer. Now, with the knowledge of how to write the algebraic expressions and then equations, then we can now be able to find the value of A. That means we are supposed to write this in terms of an equation and then find the value of A. So we are told to calculate the value of A. All these angles here are in a straight line, meaning all of them add up to 180 degrees. So A plus 2A plus 3A should give us 180. Then, because all of them are in terms of A, they are like terms, then we can be able to add. We can be able to add A, 2A, and 3A. If we add all of them together, you realize we have 6A, and that will give us 180. To find the value of A, we divide both sides by 6, because here we want to eliminate this 6 here. So if we divide 6 by 6, we have 1. That will remain A in this side. Then on this other side, 180 divided by 6, that will give us 30 because 6 goes into 18 3 times, and then we have 0 here, we bring 0. So A is 30 degrees. So let's look at this other one. We have two lines crossing each other. Then we have angle that is measuring 130 degrees. Then we have another angle that is measuring 2A plus 20, and that will give us degrees also. So we are told to find A. How do you go about this? So from what we have just discussed, we realize that if two lines cross, then we have these two opposite angles. We call them vertically opposite angles. And we said vertically opposite angles are equal. So because vertically opposite angles are equal, then we can equate the two. We can equate the two. So we'll have 130 is equals to 2A plus 20. Let us collect the like terms. Which are the like terms? You realize that 130 and 20 are like terms because all of them are numerals. They are numbers. So we will subtract 20 from this side. So that we can eliminate 20 from this end. So when we eliminate here 20, 20 minus 20 is 0. So 130 minus 20, that will give us 110 is equals to A. Let us eliminate 2 because we want to remain with A on this other end. So we divide by 2 to remain with A. If we divide 2 here, 11 divided by 2, we'll have 5. Remaining 1, then you carry 0. That will be 5 again. So A (55 degrees). So we are using the knowledge of vertically opposite angles to be able to calculate the value of A. So again, let us look at this diagram here and solve for the value of A. So we are told here is A, here is 90. This is right angle. You should be able to notice that this is a right angle, and right angle measures 90 degrees. This is 2A minus 12. So the first thing that we're supposed to do is to be able to get the equation, the algebraic equation. Be able to write algebraic equation, then we can be able to solve A from that. So this plus this plus this, that should give us 180. That is supplementary. These are not supplementary, but these are angles on a straight line. Let us now collect the like terms. So we have A, 90, 2A, and 12. So A and 2A, those are like terms. Both of them have A. 90 and 12 are numerals. They are numbers. We can be able to add the 2 because they are common. They are like terms, 3A. A plus 2A, that will give us 3A. 90 minus 12, that is 78. So 78 and 180, those are numerals. We can take them to the same side. So if we subtract 78 and 78, that one will give us 0. We'll remain with 3A on this side. Then 180 minus 78, we have 102. To be able to get the value of A, we divide by A, both sides. A, 3 and 3 will cancel out. Then we remain with A. 102 divided by 3, that should give us 34. So the value of A in this diagram here is 34 degrees. So consider this diagram. This diagram is not drawn to scale. Calculate the value of A. So we have this diagram here. We have this angle measuring A plus 50, and this one is A minus 90. So we are told to calculate the value of A. So what do we do again? You are supposed to be able to understand angles on a straight line. So angles on a straight line add up to 180 degrees. So if we add the two angles here, it should give us 180 degrees. So we write that explanation in terms of an equation. Let us now collect the like terms. So realize we have A and A. So 2A plus 50 minus 90, that will give us 180. That will give us 180. (50 minus 90, you realize that we have negative 40. So 2A minus 40, that will give us 180. We take 40 to the other side. So 2A will give us 220. We divide by 2 so that we have A on this side alone. So the value of A is 110 degrees. 110 degrees. The other part is, now explain what is wrong with the way the diagram is drawn. Is there any problem with the way the diagram is drawn? Let us see if there is any problem with the diagram. So we have found A is 110 degrees. So that means here, if we substitute the value of A in this expression here, you realize that if A is 110, then 110 minus 90, that will give us how many degrees? 20. So this angle here is supposed to measure 20 degrees. And this other side? A plus 50. A is 110. Let us substitute. That is 160. That is supposed to be 160 degrees. So here is 160. Can you now see the problem with the drawing, the diagram? So what is the problem? A plus 50 should be a larger looking angle. It should have been drawn the other way round so that So this is how it should have. This is the mistake. A plus 50 degrees should be a larger looking angle. And then this is how it should actually have been drawn, because A plus B is a larger angle, which is 160 degrees. So today we have learned about the angle relationships and properties of geometrical figures, and we started by looking at the definitions of terms that are used in this topic. So we have looked at the different types of angles. We have looked at a right angle, and we said this is an angle that is measuring 90 degrees. We have looked at an acute angle that is measuring less than 90 but should be greater than 0 degrees. We looked at a reflex angle measuring more than 180 degrees but less than 360. And we went ahead to look at vertically opposite angles, and we said vertically opposite angles are angles that are formed by two lines which cross each other, and because they share a common vertex, but one angle is at the top of the other, we said these angles are equal. So that one marks the end of our topic. Today we'll continue looking at other figures in this topic in our next lesson. Thank you.